Hi guys, welcome to Regents Prep 6. I'm going to run through the multiple choice first, so we'll start with number 1. It says a hydrated crystal and one wet. So I'm going to focus on that word hydrated. So hydrated, I'm always going to want to think water. So let's see, hydrogen molecules. Water molecules are part of the crystal. I like that. Water molecules have been removed. Ooh, I don't like removed. I want them, so I like choice 3. 2, in a balanced equation, coefficients always represent. Well, I'm going to think coefficients. I'm talking about, so if I had like 2 HCl, I'm talking about that 2 in there. So do they represent the number of atoms, the mole ratios? Oh, I think I like that. The volume or the volume ratios. I don't like volume. So I'm either number of atoms or mole ratios. And I'm going to go with mole ratios for this one. Coefficients will always give you your mole ratios. 3, the mass of a mole of a substance is equal to. So the mass of 1 mole, if I really want to figure this out, I can look at my mole equation and I can see that moles, the number of moles is your given mass over your gram formula mass. So technically, if I'm figuring out the mass of 1 mole equals some mass over the GFM. Well, if I were to put numbers in there, I'd end up multiplying these things. 1 times the GFM to solve for my X. So that means really the mass of 1 mole is just the gram formula mass of whatever the element is. So choice 3. Number 4, the term mole is a unit used to represent. Well, moles represent the number of particles. If we're going to explain this, really that is the explanation. This is Avogadro who thought of this. And remember his number was 6.023 times 10 to the 23rd. You won't really have to use that number, but you just want to know that that's how many particles Avogadro said was in 1 mole. Okay, number 5. 1 mole of carbon and 1 mole of neon both have the same. Well, we were just talking about that, so they both are 1 mole. So it doesn't really matter if it's carbon or neon. Both are going to have the same number of particles. And actually, we know that number is going to be 6.02 times 10 to the 23rd. Again, because of Avogadro's number. Number 6, to find the percent of an element in a compound. So if I want to find the percent of any element in a compound, I want to think, I can go to my reference table, and there's 2 equations I have for percent. I can either do percent air, or I can do percent composition. And it seems like if I'm doing it of an element within a whole compound, well, my element would be my part, and my compound would be my whole. So that means I divide my mass of the part by the whole. So I'm going to divide the atomic mass. Basically, I'm going to do the atomic mass of the element. And then I'm going to put the total mass on the bottom. But I want to remember, actually, it's not going to be my atomic mass. It's going to be my total mass on my element, because I'm thinking, wonder if I have, for instance, like C2H6. I would have 2 C's. So then my mass would be 2 of those. So the total mass of the element over the total mass times 100. So let's see if I can find that. Divide the total mass of the element by the total mass of the compound times 100. Number 7, what is the gram atomic mass of zinc? So remember, gram atomic mass, it's the same as the gram formula mass. If I'm going to look for it for zinc, that's Zn. I'm going to go to my periodic table, and I'm just going to look up zinc, and I'm going to see zinc is 65.409. So basically 65. Right from my periodic table. Gram formula mass, just the mass of whatever element you're looking at. The mass of 4 moles of CO2 is, so I have 4 moles of CO2, so remember your moles, that has your given mass over your gram formula mass. Remember, I'm getting that from table T. So that's what I have. I know my moles is 4. I want to know my mass because they're asking me to solve for it. And my gram formula mass, let's figure it out for CO2. So carbon has a mass of 12, plus oxygen has a mass of 16, but I have 2 of them. So 16 times 2 plus 12, that's going to give me 44. So 44 grams per mole is my gram formula mass. So 4 divided by 44. Or no, not divided by x divided by 44. And so I'm going to get choice 4. So for that, I end up going 4 times 44, cancels that out, times 44 over here. That leaves me with my x. Okay, number 9. Given the balanced equation representing a reaction, 4NH3 plus 5O2 gives me 4NO plus 6H2O. What is the minimum number of moles O2? So I want moles O2 that are needed to completely react with 16 moles of NH3. Well, I'm going to look at my mole ratios here. I'm looking at O2 and I'm looking at my NH3. So it said I had 16 and I want to know this one. So this is X. So remember, I can kind of set up a ratio and look at my original mole coefficients versus what I have now. So I'm going to go 4 over 16 equals 5 over x. I'm going to solve for that x. So I'm going to get, well, that's really 4x equals, my 16 times 5. Well, whatever 16 times 5 is, divided by 4, divided by 4. I'm going to get x equals whatever this is. I plug it in my calculator. I'm going to get 20. X equals 20. Number 10. Given the balanced equation, what is the mole ratio of CO to CO2? So I'm going to look at CO and CO2. Remember your mole ratio, that just means look at your coefficients. So I'm going to say, okay, CO was 2, CO2 was a 2, so it is 2 to 2. I don't see a 2 to 2 listed, so I can remember that a 2 to 2 is the same as saying 1 to 1, because I can just simplify it, so choice 3. Number 11, the mass of a mole of CaOH2 is. So remember, if you have the mass of a mole, so 1 mole is always equal to just the gram formula mass. So I'm going to figure out what the gram formula mass is of that CaOH2. So I'm going to look at my reference table. Ca has a mass of 40 plus O has a mass of 16, but you actually have 2 of them because that would distribute. So 16 times 2 plus H has a mass of 1, but times 2. And I'm going to get for that one 74. So choice 4. So if the mass of a mole of H2X is 34, then X must represent. So we're talking about the mass of a mole, so the gram formula mass, basically. Remember that. So H2X. So let's think of what I know. I know that H has a mass of 1, and there's 2 of them. So 1 times 2 plus something gives me 34. So I'm just going to solve for that. So I'm going to, 1 times 2 is 2, so I'll subtract 2, so I'll take 2 away from here. So that means X has to equal 32. So I'm just going to go to my reference table. I'm going to say, well, who has the mass of 32? And if you look right here, sulfur has a mass of 32. So choice 4. So that one's just kind of, you can do a guess and check if you want, if you didn't want to set up an equation. But S plus 2 H's has to give me that 34. 13, when 4 moles of C2H6 are burned, the number of moles CO2 produced will be, so they want to know this. What is this? This is X. And they know you had 4 of this. So again, let's set up a ratio between these. Look at your original coefficients versus what they're changing to. So that means I'm going to go 2 over 4 equals 4 over X. I get 2x equals 4 times 4 would be 16, which means x is going to equal 8. So 13 would be choice 4. 14, the mass of a mole O2 is, so again, remember always when they say the mass of a mole, that's your gram formula mass. So just look up O2. Oxygen has the mass of 16, but you have 2 O's. So 16 times 2 is 32. So choice 4. 15. How many moles of hydrochloric acid, so which one's my hydrochloric acid? Here it is, X, are needed to react with 5 moles of magnesium? 5 there. So the coefficient in front of magnesium is really a 1. So my original coefficient of magnesium was a 1 over a 5. And then my original coefficient was a 2 in front of my HCl over an X. So I get 1x equals 10. So really that just means x equals 10. So I'm looking in, I don't see any answers here. So we're going to put a star by this. There's actually no correct answer. What this should say, instead of 1.0, this should say 10.0 moles. And if that said 10.0, I'd choose choice 2. So if you got this originally and didn't think you were right, you were. 16. What is the total number of moles in 80 grams of C2H5Cl? They give me the gram formula mass of 64.5 grams per mole. So they want my moles. So remember, if I go to my table T, I know my mole equation. Mole is your given mass over your gram formula mass. Remember, always look on your table T. We don't want to take that for granted. It's right there, so you should never have to worry about that. They gave me a mass of 80 grams, and they said the gram formula mass was the 64.5 grams per mole. So if I solve for that, that's going to give me my moles. So I'm going to plug that in my calculator, and I'm going to get 1.24. Okay, let's go on to our short answer. So a lot of these are going to be very much the same. We're going to use a few different equations. So I'm actually going to set them up at the top here. So I can already tell from a quick scan that they're going to give me a lot of gram formula mass. So let's remember that if they say GFM, that means I'm just going to add the masses together. And I'm going to be looking at my periodic table whenever I do that. So I'm not going to show you every time, but I'll be looking right here. And remember our mass, if I'm looking, I'll kind of look at this example one. Remember your mass is always at the top. You can pretty much always just round that to a whole number. We're going to be careful of CL. You're always going to use, let's get on the screen, use 35.5 for CL. Other than that, you can round them to a whole number. They're also going to ask me a lot of things like this, number 20, the percent by mass. So remember, if they're going to ask you your percent by mass, I'm going to go to my table T. And I see right here my percent composition. It says percent composition by mass. Mass of the part over mass of your whole times 100. So mass, part, mass, whole, times 100. So I'm going to use this. Again, I got that from table T. And I'm just going to scan, is there anything else? I might use, again, we've been using the mole equation. So moles equal, remember I go back here, my mole calculation, given mass over your gram formula mass. So I'm going to just write mass over your gram formula mass. We might use that. Now I'm set up so whenever I do any of these problems, I'm just going to refer back to these. Remember, these I'm getting from table T. I always remember there. Gram formula mass is I'm looking at my periodic table. So if you're going to correct these, show me these equations. So 17. What is the gram formula mass of ethylene glycol, and then they give me the formula. So again, gram formula mass, add the masses together. I'm going to my periodic table. Carbon has a mass of 12, but times 2 because there's 2 carbons. H has a mass of 1, but I have 4 H's there, and I have another 2 right there, so really I have 6 H's, so 1 times 6. Plus, I'm going to go with my O. I really have 2 O's because that distributes, so O has a mass of 16, and there's 2 of them. And I get, let's see, 62. So 62, and then my unit would be grams or grams per mole. Okay. 18, another gram formula mass, but now with this, it's a little trickier because this is going to be a hydrate. So I'm going to just look up my masses again. Cl has a mass of 40. S has a mass of 32. Oxygen has a mass of 16, but times 4. Now onto my water. So now I'm going to say, okay, I have 2 H's, but times 2. That distributes, so 4 H's. So plus 1 times 4. Plus, that would mean I have 1 O here, but there's 2 waters, so 2. So plus another 16 times 2. And that is going to give me 172 grams per mole. 19, gram formula mass of glucose. So I have carbon is 12. I have 6 of those. Plus hydrogen is mass of 1. There's 12 of those. Plus oxygen is a mass of 16, and there are 6 of those. That is going to give me a mass of 180 grams per mole. 180 grams per mole. 20. All right, we're moving into some percent by mass. These questions right up here. Your part over your whole times 100. So, okay. They want the mass of oxygen in NO2. So I want to think, okay, what is the mass of my part and what is the mass of my whole? So I have my part is my oxygen. That's my O2. So that's 16, but there's 2 of them, so that's 32. And my whole is my NO2. So that's a mass of 14 plus that 16 times 2, which is 32. So 46. So my percent oxygen, I'm off my screen here. My percent oxygen equals my part was 32 over my whole is 46, and that would be times 100. We're squeezing that in, times 100. I'm going to get 69.57%. I'm not really worried about significant figures here. Yes, if you want to try them, you can, but you're rounding the number, so we're not really focused on that. 21, what is the percent mass of nitrogen? So again, percent mass tells me to go up here, use that equation in this. So this is my whole. Nitrogen is my part. So this one, hold on, I gotta grab my calculator here. Okay, so my whole, let's add this up. So nitrogen is 14, and there is, let's see, 2 nitrogen, so 14 times 2, plus hydrogen has a mass of 1, and there's 4 here, but times 2, so 8. So 1 times 8, plus carbon has a mass of 12, there's just 1 of them. Oxygen has a mass of 16, and there's 3 of them. So my whole has a mass of, let's see, 14 times 2 is 28, plus 8 plus 12 plus 16 times 3, 96. So 96 is my whole, And then my part, that's just the nitrogen, but there was 2 of them. So nitrogen, N2, 14 times 2, which was 28. So I've got my number. I'm going to do 28 over 96. I'll do it over here. My percent nitrogen is 28 over 96 times 100. And so when I do that, I'm going to get 29.16. Not really 17%. Okay, number 22. Calculate the percent composition by mass of carbon. So again, percent composition by mass. I'm going back up to this equation, which was on my table T. And I'm saying, okay, my carbon, let's figure out my whole. My whole Na is a mass of 23, but times 2, plus carbon is a mass of 12, plus oxygen is 16 times 3. That's going to give me, let's see, we've got 46 plus 12 plus 16 times 3, 106. As far as the carbon, there's just 1 carbon, so that is a mass of 12, and it's just 12. So for my percent carbon, my part is 12, my whole is 106, and times 100, that's going to give me 11.32% carbon. 21, what is the percent by mass of oxygen in propanol? So let's see, my oxygen is my part. I only see 1 oxygen there, so the part is 16. Let's get my whole. So let's see, you have 3 C's, so 12 times 3 plus 1. Let's see, my H is 3, 4, 5, 6, so 1 times 6. Plus I had the 1 O, so 16. So we have 12 times 3 plus 16 and 6. 58. So part 16, whole's 58. So my percent oxygen is 16 over 58 times 100. And I'm going to get 27.59%. Okay. Number 24, what is the mass in grams present in 0.8 mole sample of NaNO3? And they say the gram formula mass is 65 grams per mole. So they want a mass and they're giving me moles and a gram formula mass. So I should go up and I'm going to look on my table T, but I'm going to use moles as your mass over your gram formula mass. So let's see. I had 0.80 moles. That equals my mass is X. My gram formula mass was 65. I'm going to solve for that X. So I'm going to get X equals 52 grams. 25. Some dry chemicals are used to put out forest fires. One of these chemicals, NaHCO3. When NaHCO3 is heated, one of the products of CO2 is shown in the equation. Determine the number of moles CO2 produced when 7 moles of NaHCO3 is completely reacted. So they give me an equation here. They're saying now instead of having, remember this would be a coefficient of 1. So instead of having 1 of the NaHCO3, they're saying now you have 7 moles of it, 7.0 moles. And they want to know, well, how much CO2 then if you have that? So you're going to set up your ratio. So you're going to go 1 over 7 equals really 1 CO2 over X. So you get X equals 7. They're a 1-to-1 ratio. So it's the exact same. 7 moles. 26. What is the number of moles, O2, that are produced when 8 moles of Al2O3? So I have 8 of those. I want to know about this. So again, let's set up my ratio. 2 over 8, original over new, equals original over new, 3 over x. So 8 times 3, 24. So I get 2x equals 24. That means x equals 12 moles. 12 moles. Okay, almost there. Not too many left. So what is the total number of moles O2 produced when 8 moles of H2O is completely consumed? Again, I'm going to set up a ratio. I'm going to put an 8 here. I'm going to put an x here. I'm going to look at my original coefficients. That's really a 1. 2 over 8 equals 1 over x. So 2x equals 8. So that means x equals 4 moles. 4 moles. For all of these, you're just setting up a ratio. 28, what is the total number of moles O2? So that's x. That must completely react with 8 moles of Al in order to form Al2O3. You don't really care about this part. You really care about your moles O2, and you had 8 of these. So again, a ratio, one more time, 4 over 8 equals 3 over x. So you get 4x equals 24. So that means x equals 6. 6 moles. 29. Explain the difference between a molecular and empirical formula. You want to remember that empirical always means it's simplified. So it's the simplified formula, we'll say. Where molecular, it's not simplified, so it's the actual formula. But the important part here is that you're focusing on the empirical simplified. 30. What is the empirical formula of aspirin in C9H8O4? So empirical formula, they want me to simplify if I can. So let's see, do we have any common numbers? 9, 8, and 4. I don't see any common numbers, so actually this is already simplified. So it's already simplified. But I can't just say that. I got to just reiterate that that's the same formula. So I will just say it again, C9H8O4. If I can't divide all of them by the same number, I can't shorten it. Okay, last 3 questions. We're almost there. Now I want to be careful up here because it says a student places a 2.5 gram sample of magnesium in a bottle and adds hydrochloric acid. The acid reacts with magnesium to produce hydrogen gas and MgCl2, and they show us the equation. So 31 says balance the equation using the smallest whole number. So I'm going to say, okay, 1 mg, 1 mg. 1 H, 2 H's. Let's put a 2 right here. 2 Cl's, 2 Cl's. Actually, that 2 is the only number I need. The rest of them have 1s in front. So 32 says how many moles of magnesium were used in this reaction. So it would be very tempting to go up here and say 1 mole. That would be very tempting. Because if you're looking right here, that would really be a 1. But that is not the answer. You want to go back up here and again focus on this. You had a 2.5 gram sample. So you know that moles is your given mass over your gram formula mass. So do the math. 2.50 grams is given. Gram formula mass of magnesium, I go to my periodic table, Mg has a mass of 24. So when I do that, I do 2.50 divided by 24, and I'm going to get your moles is 0.104. Moles. 0.104 is the actual answer. So you had to figure that out because up here they told you you had a mass. So you had to use your mole equation. Table T. So 33, how many moles of magnesium gas were produced if all of the magnesium reacted? We'll go back up here. Notice that you have a 1-to-1 ratio. So if you have a 1-to-1 ratio, then that means if you had 0.104 moles of this Mg, then you have 0.104 moles of your H2. It would be exactly the same because it has the same mole ratio. All right, thanks, guys. Good work with this Regents Prep. And make sure you know all the math, and make sure you're always using a calculator, and you're always looking at your periodic table. Little mistakes will be your downfall, if any, on these. Thanks, guys. Great job.